Good evening guys, welcome to Videos Online Academy Tutorial. Thanks for watching our videos online. Please, if you have not yet subscribed to this YouTube channel, please do well to press the subscribe button and the notification bell in order to see all of our educative videos online. Please also remember to share this video with your friends, family, relative and words at home, and so as also they can also be beneficial of these videos. Help us to make this channel known by liking the board videos and subscribing as well. Thank you and God bless you. Today we are going to be considering the subject of chemistry and the topic in particular gas law. I'm talking about gas. Gas is one of the state of matter in which the molecules are in a constant random motions, and these molecules they collide with themselves. These molecules are not closely packed together. They have space. They have maximum space within one another, and these molecules collide with one another and also collide with one another and also collide with the wall of the container. The container, you can see they are moving in a random motion, and there are laws guiding these gas molecules, and these are the things we are going to consider today. We are going to be considering the law guiding these gaseous molecules of any given substance. And here we are going to be considering almost 7 laws, and the first law here is what we call Boyle's law. Boyle's law is the first law that we are going to be considering. Boyle's law states that the volume of a fixed mass of gas, is inversely proportional to the pressure of the gas at constant temperature. Boyle's law states that the volume of a fixed mass of gas is inversely proportional to the pressure of the gas at constant. What means by this law? It says that as you increase the volume of a gas, if you increase the volume of a gas, there will be a decrease in the pressure of that gas, or vice versa. If you decrease the volume of a given gas, the pressure will increase. That's what we mean by inversely proportional. So it's saying that the volume of a gas is inversely proportional to the pressure, and pressure is as a result of overcrowding. And whenever these molecules collide with each other or with the wall of the container, they produce pressure. The smaller the area of the container, the higher the pressure. So when you increase the pressure of a given gas, the volume will decrease, and when you increase the volume of a given gas, then the pressure will decrease. So that's what Boyle's law was saying. And mathematically now, Boyle's law was saying that the volume is inversely proportional to the pressure, provided that the temperature remain unchanged, provided that the temperature is constant. Provided that the temperature is constant. So provided that the temperature is constant, temperature is constant. So that's the mathematical expression. So V is equal to what? K over P. When you cross multiply, we have PV equal to K. So in other words, now we can now have P1 V1 equal to P2 V2. Now that's that about Boyle's law. So P1 V1 equal to P2 V2 equal to PN VN, whichever the case might be. So, and here we can represent the Boyle's law using graphical representation. So now Boyle's law can be represented as this in 2 ways. It can be represented using graph. Boyle's law can be represented in 2 ways using graphical notation. So the first one is like this. When you have the volume, against the pressure, we have P against volume. We are going to have all. But when you have P against inversely proportional to V, you are going to have a straight line graph. So these are the 2 representations. P against V. We are going to have something like a curve like this, and P against inversely proportional to 1 over V. or it can also be V1/P. It's still the same thing. So this will be straight line. So this is the graphical representation of both graphical what? Representation of what? Of Boyle's law. Of Boyle's law. Now, so that's that about Boyle's law. Say that the volume of a given mass of gas is inversely proportional to what? To the pressure of that gas, provided that the temperature is what? Is constant. Now, the second law that we're having here is what? Is Charles' law. Charles' law. Charles' law. Now, Charles' law states that the volume of a fixed mass of gas is directly proportional to the temperature of the gas in Kelvin, provided that the pressure is constant. The volume of a given mass of gas is directly proportional to the temperature in Kelvin, provided that the pressure is held constant. So mathematically now, the volume of a given mass of gas is directly proportional to the temperature in Kelvin. The temperature is in Kelvin, provided that the pressure is what? Pressure is constant. Provided that pressure is what? Is constant. So don't forget that this temperature is in what? Is in Kelvin. I will call that temperature absolute what? Absolute temperature. So this temperature is in Kelvin. Temperature in what? In Kelvin. Temperature in Kelvin, which is K. So when you place the constant of what? Proportionality, we have what? V equal to what? KT. In other words, when you make K solid formula, we have what? V over what? Over T equal to K, which can also be written as what? V1 over T1 equal to V2 over what? T2. Now, note that the temperature here is always in Kelvin, and we can convert what? The temperature from degrees Celsius to what? To Kelvin. So you want to convert temperature, conversion of what? Temperature, conversion of temperature, conversion of temperature in degrees Celsius to what? To Kelvin will be what? T in Kelvin will be equal to what? Degrees Celsius, temperature in degrees Celsius plus what? 273. So note this as the conversion for what? From temperature in degrees Celsius to what? To Kelvin. And we can also represent what? Charles' law using what? Graphical what? Representation, which is like this. So if you want to represent what? The Charles' law using graphical representation, we are going to have what? We are going to have V against what? Against T in Kelvin. So there's an extension from here that bisects the what? The y-axis, which is the volume axis. So we have, this is what? 0, this is what? Minus what? Minus what? Minus 3 degrees what? Celsius, this is 273, and so on and so forth. So this is volume against what? Against temperature, and this is the graphical representation of what? Charles' law. Now let's go to the what? To the third law, which combines the what? Both the Boyle's law and what? Charles' law together. So we call it what? General what? Equation. General equation. So third law that we have here, number 3, the third law that we have here is what? General what? Gas equation. General gas equation. We are talking about general gas equation. General gas equation combine what? This combine the Boyle's law and the word Charles' law together. The Boyle's law and the what? And the Charles' law together. And Charles' law. This combine the Boyle's law and the Charles' law. So we have what? V is what? Inversely proportional to what? P, and V is directly proportional to what? C. So we have V equal to what? V directly proportional to what? 1 over P dot what? Dot T. So we have V is directly proportional to what? T over P. When you introduce the constant now, we have what? V equal to what? KT over P. So when you cross multiply here, so this is PV equal to KT, making what? T this case of formula, we have what? PV over what? T equal to what? K. So in other words, we have what? General gas equation now. General gas equation. We have general gas equation. General gas equation. General gas equation is equal to now. Is now what? P1 V1 over what? P2 V2. Okay. P1 over V1 T1 over T1 equal to P2 V2 over what? T2. So this is the general gas what? Equation. It combines both the Boyle's law and the Chap's law, and that's that about that. Now, when we move to the next one, we have what? Something we call what? Avogadro's what? Avogadro's law. Avogadro's law. Avogadro's law. Avogadro's law state that equal volume of gases at the same temperature and pressure, equal volume of gases at the same temperature and pressure contain the same number of what? Of molecules. Contain the same number of molecules. Now, it said that equal number of volume of gases, equal volume of gases, equal volume. Avogadro said that equal volume of all gases at constant temperature and pressure contain the same number of what? Number of what? Molecules. So it's saying that what? At constant temperature, the volume of all gases is directly proportional to what? To the number of what? Moles. So the volume of gas is directly proportional to what? To what? To the number of molecules of that gas, provided that the pressure and what? And the temperature is constant. Provided temperature and what? Pressure is what? Constant. Provided that what? The temperature and what? Provided that the pressure and temperature are constant. So are constant. Please note that are constant. So in other words now, so we have what? V is directly proportional to what? A. That's what Avogadro said. Temperature and pressure are what? Are constant. Are constant. Are constant. So these are constant. So that's that are constant. So temperature and pressure constant. So that's that about that. Now that's Avogadro's law. Now when you now combine Avogadro's law together with what? Boyle's and Chap's law, we have what we call an ideal what? An ideal gas equation. An ideal gas what? Equation, which is our fourth one. An ideal gas equation. Now when I'm talking about an ideal gas is a gas that obeys the Chap's law, Boyle's law, and Avogadro's what? Law. So an ideal gas law is what? Is a gas that obeys Boyle's law, Chap's law, and what? Avogadro's law. So meaning that an ideal gas equation is derived from Boyle's law, Chap's law, and what? Avogadro's law. So we know that the Boyle's law is says that volume is directly proportional to is inversely proportional to what? P. And we know that what? Chap's law states that the volume is what? Is directly proportional. This one, the Boyle's law states that volume is inversely proportional to what? Pressure. Chap's law states that the volume is directly proportional to what? Temperature. And the what? Avogadro's law states that V is directly proportional to what? To the what? The number of molecules of what? Of the gas. So now we now combine this. Since they are having volume, same volume, we have what? V is directly proportional to 1 times T. We have what? T times N, and we have NT over what? P. So when you introduce constant, now this constant we call it gas constant. So which means that we have V equal to what? RT over what? P, where R is the molecular what? The molar gas is what? Is what we call molar gas constant. Molar gas constant, which has a value of what? Which has the value of 0.082 atmol dm cube per mole per Kelvin. Now look at this. It has a value of 0.082 atmol per dm per mole per Kelvin, provided that the what? The pressure is measured what? This is for when pressure. This is for when pressure is measured. When pressure is in what? ATM. When pressure is in ATM, provided that the pressure is in ATM, and what? And the volume is in what? Is in dm3. Provided that what? The pressure is in ATM and the volume is in what? Is in dm3. That's when this one is applicable. So, but however, when you what? However, when the pressure is in what? In Newton meter square and volume in meter cube, the value of what? The value of R is 8.314 joule per mole per what? Kelvin. So whenever the volume, whenever the volume is in meter cube and the pressure is measured in meter square, we have 8.314 joule mole per dm cube per Kelvin. So that's that. So note the value of what? Note the value of what? R. The two values of R. This one and this another was 1. So I know when you have to apply it depending on what? On the unit. Now this is an ideal what? An ideal gas, and we have what we call standard what? Temperature and pressure. Now this Avogadro's law states that, before I forget, it states that Avogadro says that one mole of the gas contains 22.4 dm cube at STP. So Avogadro says that what? 1 mole of any gas contain what? Contain 22.4 dm cube at ST what? P. When I'm talking about STP means what? STP means what? Standard what? Standard temperature. Standard temperature and pressure. Also, at that standard temperature and pressure, T is 273 Kelvin. Pressure is in what? Is what? 1 atmospheric pressure, or it can be 760 millimeter mercury when they measure it in millimeter mercury, which is also equivalent to what? To 101325 Newton per meter square. All these things are the same thing. 1 atmospheric pressure, 760 millimeter mercury. It's just that the unit is different. Whenever you are measuring pressure in Newton meter per second square, use 10325 Newton meter square. But whenever you are measuring it in millimeter mercury, use 76 for standard temperature. Whenever you are measuring in atmospheric, use 1 atmospheric pressure. So and also our standard temperature and pressure, the volume is 22.4 dm cube. So please note this constant as we are going to be using it in calculation the subsequent problems that will follow. Now that's that about general gas question, ideal gas question, Avogadro's law. Now let's go to law state that when gases react, they do so in volume which are in simple ratio to one another. So now it means that the ratio by which they react will determine also their volume. So if 2 mole of hydrogen gas react with 1 mole of oxygen gas, meaning that 2 volume of hydrogen gas will react to 1 volume of oxygen gas. So that's what Lucas was saying. He's saying that when gas reacts together, they do so in terms of volume, which is similar to the simple ratio. That's just about the Lucas law of combining volume. We call it the Lucas law of combining volume. So when gas reacts, they do so in volume, which is equivalent to the simple ratios. So that's that about the user. We know how to apply it in our subsequent problems. So in our 7, Dalton law Now I talk about Dalton law. Dalton law says that when two gases mix together, that is, they are not chemically what bonded together. When two or more gases mix together, meaning they did not react together chemically, the total pressure exerted by the gas will be equal to the to the sum of individual partial pressure of the component gas present in in the mixture. I repeat myself again. That law says that when two or more gases are mixed together, that is, they exist as a mixture, the total pressure exerted by that mixture of gases is equal to the sum of individual partial pressure of the component gases in mixture. So meaning that if I have a gas if I have a mixture of gas A, if I have a mixture of if I have a mixture of a mixture of gas A, B, and and C. So he's saying that the total pressure of that gas will be PA plus PB plus PC, and so on and so forth. They are more than that. So that's what that law is saying, that the total pressure will be PA plus PB plus PC, and also the total molecules of the gas. The total molecules of the gas will be equal to Na. That's the number of moles of the number of moles of gas A plus number of moles of gas B plus number of moles of gas C. And each of these partial pressure of individual component of gas can be obtained as PA equal to Na all over Nt multiplied by P total. Multiplied by total. Know that this multiply. So multiplied by P total. So meaning that also PB can be obtained as NB over NT. Know that the N total multiplied by PT, and also PC is equal to NC over NT multiplied by PT. So that's the partial pressure of gas A, partial pressure of gas B, and partial pressure of gas C. So know that this is the number of moles, where N is where N is number of number of moles, or number of molecules, number of moles of gases. So number of moles of gases, P T is the total pressure. While P A, PB, PC are partial pressure of A, B, and C. So that's that about Dalton law of partial pressure. And lastly is the Graham's law of diffusion. Graham's law of diffusion. Graham's law of diffusion states that Graham's law of diffusion. I'm talking about Graham's law of diffusion. When I'm talking about diffusion is the movement of gas molecule from a region of higher concentration to a region of lower concentration until equilibrium is reached. It means that gases flow or spread from a region of higher concentration to a region of lower concentration until equilibrium is reached. Now, the Graham's law of diffusion is now saying that the rate of diffusion of any given gases or of a given gases is inversely proportional to the square root of the vapor density or relative molecular mass at constant temperature and pressure. Now I repeat myself again. The Graham's law of diffusion states that the rate of diffusion, that is the rate at which the diffusion of a gas takes place, is inversely proportional to the square root of the vapor density or the relative molecular mass, how heavy the gas is, at at constant temperature and pressure. So now the rate at which a gas moves from one place to another depends on how that gas is heavy in terms of what? In terms of density. So square root of that density. So it's not just what ordinary density, but the square root of that vapor what? Density. So mathematically now we have what? Mathematically we have the rate is inversely proportional to the square root. Rate is inversely proportional to the square root of density, that is the vapor density of that gas. Remember this square root, or it can what? Rate inversely proportional to what? To square root of molecular what? Relative molecular mass. So whichever the case, please note that. So if I'm considering what two gases now, it's now what? Now let me consider the what? The density now. It's now what? R1 equal to what? R equal to K over what? Root what? D. R equal to K over root D. So if I cross multiply, I'm going to have what? R root what? D. So equal to what? K. Same thing happens to what? When I use what? R directly equal to what? K over M, which is what? The relative molecular what? The relative molecular mass. So when I cross multiply, we have what? R root what? Root M equal to what? K. So that's that about that. So if I now so from here now, so we have what? R is density equal to K, or you can have what? R what? Root what? M equal to what? K. So you can now extend it to be R1 root D1 equal to what? R2 root what? D2. Or you can use your relative molecular mass, R1 root M1 equal to what? R2 root what? M what? 2. So I'm going to have what? R1, and you bring this one together with, when you bring this one down into this to be R1 over root R1 over R2 equal to what? Root, and you take this one to this place, root D1 over root what? D2. So the same thing applies to this one. R over R2, we are using what? Over root M1 over what? Root what? M what? M2. So meaning that what? I can enclose like this. R2 equal to what? Root D1 over what? D2 equal to, or R1 over R2 equal to M1 over what? M2. Note that the molecular, this is what? The relative molecular mass. Note that the relative molecular mass, the relative what? Molecular mass of any given compound, the relative molecular mass of a compound, which is what? Which is M equal to what? 2 times vapor density D. So please note that the relative molecular mass, which is termed in here, is 2 times vapor density, that is D. So that's that about that. So we have summarized the law, the gas law. Now let's go into how we can apply this law in calculation. So here is the question before us. The first question says that solution to the jump question before us. At 25 degrees Celsius and 1 atm, a gas occupies the volume of what? 1.50 atm. Now at 25 degrees Celsius and 1 atm, a gas occupies the volume of 1.50 atm. What volume will it occupy at 100 degree Celsius and 1 atm. Now look at this, look at it very well. The temperature given to us is what? T1 here is 25 degrees Celsius. Now remember we have to take this degree Celsius to Kelvin plus what? 273. When you multiply 20 plus 273 plus what? 25, you are going to have 298 Kelvin. When you press it, you are going to have 298 Kelvin. Now the pressure here is in atmol. So P1 here, P here is what? P1 is what? Atmol. And that gas occupies a volume of what? Of this is supposed to be in dm cube. Occupies a volume of what? 1.5 dm cube because it's a volume. So volume V1 equal to 1.50 dm what? Cube. What volume will it occupy at 100 degrees Celsius? Now they are not saying what volume will it occupy, that is V2. If V1 is what? 1.50, what volume will now occupy at what? Temperature T2, which is what? Which is 100 degrees Celsius. Now plus 273 to take it to what? To Kelvin is 283 Kelvin. When you add 100 is 280 what? Okay, 3, this is 100 plus 273, that is 373 what? Kelvin. 273 Kelvin. 273 Kelvin. So now what will be the what? What volume will it occupy at 100 degrees Celsius and 1 atm. Now they are saying that the P2 is also what? 1 atm. So now note here that P1 is equivalent to P2 here, which is what? 1 atm. Now which law answer the same what? The same pressure all through. So we are going to look at the law that says at constant pressure. At constant pressure, which law says that at constant pressure? When you look at what? This Charles law says that the volume of a given mass of gas is directly proportional to what? The temperature at constant pressure. Meaning that this is Charles law because the pressure remains unchanged throughout the reaction. See, 1 atm, 1 atm, 1 atm, 1 atm, 1 atm. So we are going to use Charles law here. So using Charles law now, because the pressure is unchanged. So using Charles law, we have V1 over what? T1 equal to V2 over what? T2. So we have what? V1 over T1 equal to V2 over T2. So we have to calculate what? V2. So let's substitute now. We have 2. V1 is what? 1.50 over what? T1. This is 298 equal to what? V2. That's what we are looking for. Over T2. 373. So when you cross multiply, what do we have? When you cross multiply, this one times this, we have what? This one times we have what? 298 V2 equal to 1.50 times 375. So the values are like 298. So we have this one cancelled out. So when you press this 1.5 times 373 over 298, we are going to have 1.877 dm cube. So 1.877 dm cube. I tried on calculator. So okay, we have 1.88 to the decimal place. When you approximate this one now, you are going to have what? When you approximate this one will be 1.88 dm cube. So that's the answer, 1.88 dm cube. So option what? A. Option A. So that's that about that. Now a gaseous mixture of what? 80.0 gram of oxygen. Now this is number 2 here. Number 2. A gaseous mixture of 80.00 gram of oxygen. Now the mass of oxygen here, that is what it said. The gaseous mixture of 80.00 gram of oxygen. Now there is a gaseous mixture. Two gases are being mixed together here, oxygen and nitrogen. So now the mass of oxygen here is what? Mass of oxygen here is what? 80 gram. And 56 gram of what? Mass of nitrogen is 56.00 gram. Now, oxygen exists as molecule, that's right, O2. Hydrogen also exists as molecule, that's N2. So that is the mass as a total pressure. So the PT, the total pressure of the mixture of the gases is 1.8 atm. Now, the partial pressure of oxygen in the mixture. What is the partial pressure of oxygen? That's the PO2. Is what? Now, this is what? When they say partial pressure, this is Dalton law of partial what? Pressure. So we are using Dalton law of what? Dalton law of partial what? Pressure. Dalton law of what? Partial pressure. So how do we use it to calculate what? Oxygen. We know that what? The PT is equal to PO plus what? That's why he said that the total pressure of the gas is equal to the sum of the individual partial pressure. So it means that what? The total pressure of a given mass of a mixture, the partial pressure of what? Of a gaseous mixture is equal to the sum of the individual components of the what? Of the mixture. So now, so the PT is equal to the partial pressure of oxygen plus the partial what? Pressure of nitrogen. So, and how do you get the partial pressure of oxygen? The partial pressure of oxygen is given as what? The N of O of oxygen, if you remember that very well, over the NT, that is the total what? Number of moles, multiplied by the total what? Pressure. The number of moles of oxygen over what? The total moles of what? Of the pressure together, multiplied by what? The total pressure. Now, how do you get what? The mole of oxygen. Now let's follow that. The number of moles of oxygen can be calculated. The number of moles of oxygen, which is NO2, will be equal to mass of oxygen over molar mass of what? Of oxygen. Please know that number of moles of oxygen equal to mass over what? Molar mass of oxygen. Now, what is the mass of oxygen? 80 all over the molar mass of what? Oxygen. Oxygen is what? 16. Oxygen is 16. Multiplied by 2, it will be 16 times what? 2, which is 80 over what? 32. 80 over 32 will give us 2.5 mole. What is the mole? Also, that of nitrogen, number of mole of nitrogen, because we did it. We need that of nitrogen to calculate what? NT. So we add NO2 plus NN2 to get what? NT. So now we have that of mass of nitrogen over molar mass of what? Nitrogen. So which is equal to molar mass of nitrogen is what? 56 over what? Nitrogen is what? 14. The mass of atomic mass of nitrogen is 14. So 14 times 2 will be what? 56 over what? 28. So 56 over 28 will give us 2 mole. So now the NT now, which is the total mole of what? Mole of oxygen plus the mole of what? Nitrogen. Mole of oxygen plus mole of nitrogen. So we have what? 2.5 plus 2.0. So we have what? 4.5 mole. That is the total mole. So coming back to this formula now, can I get our partial pressure? The partial pressure of oxygen now will now be what? The mole of oxygen, which is what? What's the mole of oxygen? 2.5 over what? 4.5 times what? The total pressure 1.8. When you look at this very well, 25 divided by what? And if you change this one to 25 divided by 45 by 100, so it is going to give you what? Exactly 1.0 atm. So the answer here is what? 1 atm. 1 atm. So that's our number 2. Number 3 says that what? Which of this is, look at this. We have the pressure of the atm. There is 1 atm. The pressure on the vertical axis 1 atm, 2 atm, 3 what? atm against the PV. Now you can see that this line here, this one is increasing, is changing, it's increasing. Now this one is a curved line, and this one is exactly on what? 1.0 atm. So which means that an ideal what? Gas is a gas that has what? One molecule, that will be what? An ideal equation. And an ideal equation contain number of what? Molecules of 1. And what? And at what? At standard pressure, which is 1 atom. So an ideal gas, which of the curve represent the behavior of 1 mole of an ideal gas. So 1 mole of an ideal gas has what? 1 atmospheric what? Pressure. So, and whenever an ideal gas has 1 mole, 1 atmospheric pressure, definitely we call that gas an ideal what? Gas. So because this pressure now is on 1 atmosphere, so we said it will be is an ideal gas. So this curve represents an ideal gas. So curve what? What? This curve from figure 4 is an ideal gas because it has what? The pressure of what? 1 atmosphere. Pressure of 1 atmosphere. So this is D. This is D. Which of the following is true of a sample of hydrogen gas? Whose mass is 4.0 gram. Which of the following is true of a sample of hydrogen gas? Whose mass is what? 4.0 gram under a pressure of 2 mole. The mass of hydrogen gas has what? 4.0 gram under a pressure of 2 atmosphere and temperature of what? 273 what? And temperature of what? 27 degrees Celsius. Given that hydrogen is 1, R is 0.02 atm per mole per Kelvin. You can see 0.082 liter atm per mole per Kelvin. This liter here is written as well dmk. So the atm here is the pressure is in atm, and the pressure here is also what? The atm. So we can use 0.082. So now to solve this question number 4, to solve this question number 4. So how do we go about it to solve this question number 4? We have the mass of what? Hydrogen equal to 4.00 what? Gram. We have to take it to number of moles because this question looks like we have the mass, we have the pressure, we have the temperature, we have the what? The gas constant. So we are going to use what? The ideal calculation was the PV equal to what? nRT. So in order to use PV over equal to nRT, you have to look for the number of moles of hydrogen. And number of moles of hydrogen is equal to mass of hydrogen over what? Molar mass of hydrogen, which is equal to 4 hydrogen gas. Please know that this hydrogen gas, not just ordinary hydrogen. Hydrogen exists as a gas, so it is H2. So 4.0 equal to what? Hydrogen has atomic mass of 1, so 2 times 1, so which is equal to 4 over 2, which is what? 2 mole. So hydrogen is having 2 mole. Now the temperature is what? The pressure is at 2 atmospheric. The temperature is also what? 27 degrees Celsius, taking it to what? So 27 plus 273 is what? 300 what? Kelvin. So I will have to calculate what statement is true about this. So I'm not even given the options. So let's just calculate what? The volume. Now which are the volume? So the volume, let's calculate the volume now. So that's the only thing that we don't know here. So the volume here is equal to, I guess we have to calculate what the volume. Volume here is equal to what? nRT over what? P, because we are not given the what? Volume. So we have what? Your N here is 2 multiplied by 0.082 times T is what? 300 over, now your P is what? 280 280. So now that's how you obtain volume of this gas. Which of the following is true about the sample? So this sample we have volume, we don't have know the volume. So that's why we are obtaining the volume. So volume equals nRT over P. So these two will cancel to 0.082 multiplied by 300. So when you multiply it on calculator, I'm going to have 24.6 what? dm what? So that's that about that. So it means that this gas we have what? The volume of what? 26.6 the 24.6 dm key. You know that the dm key is written as what? Liter. Then they give us 0.08 liter 8 atmo here. So 1 dm key is equivalent to what? 1 liter. So if you are calculating, if you are given a liter, it means that total value 1 dm key. So that's why I have 24.6 dm key, or you can write 24.6 liter. So that's that number 4. Now let's move to the first question. Says that the pressure of 100 centiliter cube of oxygen at 35 degrees Celsius is 750. Now the pressure of 100 centiliter cube of oxygen at 35 degrees Celsius is what? 750 milliliter mercury. Now the pressure of 100 centiliter cube. So the volume here is what? V1 is 100 centimeter cube. When you see volume in centimeter, you see something in centimeter cube, it means volume. The pressure of 100 centimeter cube of oxygen. So the volume of oxygen is 100, and the pressure at this temperature T1 equal to 35 degrees Celsius. When you add it to 273, what do you have? That is 8. That's 308 Kelvin. When you press your calculator, you get what? 35 plus 270 is 308 Kelvin. So, and the pressure here, P1, is what? 750 millimeter what? Mercury. What will be the volume of the gas if the pressure is reduced? What will be volume? Know that. What will be the volume of the gas if the volume is reduced? What will be the volume of the gas if the pressure is reduced? What will be the volume of the gas if the pressure is reduced to 100 millimeter mercury? Without, is very, very important, without changing the temperature. Without changing the temperature means that this temperature T1 is same thing as well temperature T2, which is what? 308 Kelvin. This means it's a constant. This is a constant what? Temperature. Constant temperature. Whenever you're having a constant temperature, which law is applicable? Constant temperature. Whenever you're having constant temperature, which law is applicable? That is what? Boyle's law. That is, the volume of a given mass of gas is inversely proportional to what? To the pressure at constant what? Temperature. So we use what? P1 V1 equal to P2 V2. So that's Boyle's law for you. So P1 is what? 750 multiplied by V1 is 100 equal to P2 is equal to 100 multiplied by V2 we are looking for. So just divide both sides by 100. This one cancels out. 100 cancels this one. So V2 is equal to 750 centimeter cube. You know that it's centimeter cube because it's also centimeter cube. So 750 centimeter cube. Option what? D. Option D. So now number C. Question number C says that the rate of diffusion of gas Z is twice of that of Y. If the relative molecular mass of Y is 64, and the two gases diffuse under the same condition, find the relative molecular mass of what? Of Z. If the rate of diffusion of gas what? Z is twice that of Y. So the rate of diffusion of Z is 2 multiplied by that of what? Y. The rate of diffusion of Z is twice that of what? Y. It then says the relative molecular mass of Y, My is equal to what? It's equal to 64. What is the relative molecular mass? Find the relative molecular mass of what? Of that of Z. So this is a Graham's law of diffusion, because it's dealing with it of diffusion. Graham's law of diffusion. So they have what? The rate of diffusion of one gas. The rate of diffusion of a gas is inversely proportional to the square root of the molecular mass, because we are given molecular mass here. So if I'm taking R1 over what? R2 equal to what? The square root of what? R2 M what? M2 over what? M what? 1. So I relate it. So if Ry is here Ry over Rz, then Rz will be over Ry. So please don't be confused about that. So when you put that now, substituting your value now into this now, we have what's the Ry? Ry is Ry. Ry will be Ry because it didn't give us Ry. But Ry will be Ry. Why Rz is what? 2Ry. Rz is what? 2Ry. So Ry over 2Ry equal to what? Square root of M2. What is your M2? M2 is same as what? Mz here, which is what? Which is unknown. That's what we are looking for. All over what? My, which is what? 64. So it's square both sides. This one. Okay, you square both sides. But before you square both sides, Ry cancel Ry. Please note that. Before you square both sides, Ry cancel Ry. It means 1 over 2 equal to what? Root what? Mz over 64. So to remove the square root now, you square both sides. This one cancel out. So we have what? 1 over 4 equal to what? Mz over what? 64. So by cross multiplication, we have Mz equal to 64. Divided by 4. Mz equal to what? That is 16. So that is 16. We have the answer. Here is option D. So number 7. Look at this. Number 7 here. 50 centimeter cube of hydrogen as packed with 20 centimeter cube of what? Oxygen. 50 centimeter cube of hydrogen as packed with what? With 20 centimeter cube of what? Oxygen at 100 degrees Celsius and 1 atmospheric pressure. The total volume of the residual gas is that. Whenever you learn about what you are asked about the residual gas, just note that, and we are given in terms of volume. Just know that we are talking about the result law here. 50 centimeter cube of hydrogen gas was reacted with what? Oxygen what? 20 centimeter cube of oxygen. You can see that this volume of oxygen is reacted with this volume of oxygen. So we are talking about the loser law of combining volumes. We are combining reactants together in terms of volumes. So this is under what? The loser what? Law of combining, the loser law of combining volume. Please note that. Of combining volume. We look at the law of combining volume. So we are dealing with hydrogen gas now. Reacted with what? Oxygen. Now, when hydrogen is being reacted with oxygen, what do you have? Definitely we are going to have water. So this is gas. Here is gas. You have to write the balance equation, and this is what? Liquid. So now 2 molecules of gas must react with what? So you have to put 2 here. When you put 2 here, you have to put 2 here. So it's a balance equation. So meaning that 2 ratio, I think they are in 2:1 and 2:1. 1 mole of this reacts with 1 mole of this. Meaning that 2 volumes of what? Of hydrogen react to 1 volumes of oxygen. Look at this. Of oxygen. So 2 volumes of hydrogen. So now we are using 20 centimeter cube of what? Oxygen. So if we use 20 centimeter cube of oxygen here, 20 centimeter cube of oxygen here, definitely we are going to use 2 times what? 2 times what? 20 here, which is 40 centimeter what? Cube. So 40 centimeter cube will react with what? Of hydrogen will react to 20 centimeter cube of what? Oxygen. Now, and 50 centimeter cube of hydrogen was supplied. So meaning that an excess hydrogen was supplied. So meaning that the residual what? Gas, the residual gas, which is the gas that will be left behind, will be equal to that. It will be all hydrogen, which is provided excess. So which is 50 minus 40. So 50 minus 40, which is equal to 10 centimeter cube. So hydrogen is the resistor. So hydrogen gas 10 centimeter cube of hydrogen gas is left behind as residue. Is left behind as residue. So that is 10 centimeter cube of hydrogen gas is left behind as residue. So option what? B. This question here says that 16.8 grams of sodium hydrogen triazocarbonate 4 is completely decomposed by heat. 16.8 grams of sodium hydrogen triazocarbonate 4 is completely decomposed by heat. Calculate the volume of carbon dioxide given off at STP. Now, calculate the volume of carbon dioxide given at STP. Now, this was decomposed when you heat them. That's what it was decomposed by heat. So, sodium hydrogen triazocarbonate 4. You need to write the molecular formula for that and write the balance equation for decomposition. So, sodium hydrogen triazocarbonate 4 is a what? It's a solid. When you apply heat to it, this is symbol for heat. It decomposes to what? To form what? N2CO3, that is caustic soda plus CO2 plus water. So that is likely to be our product. Now we have to balance this equation. This is soda having sodium 2. So we put 2 here. So Na2, look at this, Na2, after Na2. How many hydrogen? 2 hydrogen. How many carbon? 1 carbon. How many oxygen do we have? We have 6 oxygen. We have 3 oxygen here, 2 oxygen here, making 5 plus 1, making 6. So this is a balanced equation. So now, if you have a balanced equation, now you can see that we are asking of what? We are told that at STP. So we are talking about molar volume here. Molar volume at STP is what? 22.4 dm3. So we are going to relate the number of moles of this with the number of moles of what? Oxygen produced. Then we relate the moles to what? To volume. Because Avogadro law said that at the same temperature and pressure, same volume of a gas contains equal number of moles. That is, so now 2 mole here, we can see that 2 mole of NaC yield what? Yield 1 mole of carbon dioxide that we are concerned of. So 2 moles of this. So meaning that in terms of gram, now since they give us a gram, I'm going to take that what? These 2 moles into what? Into gram of this. So it means that 2 into bracket the molar mass of it. That's why we are given this 23 plus 1 plus what? 12 plus what? So 23 plus 1 plus 12 plus 3 multiplied by 16. That's the oxygen is 16. So please remember that. So oxygen is what? 16, then big bracket. Yield what? Yield 1 mole. And 1 mole of CO2 occupies what? 1 mole of CO2 occupies what? 22.4 dm. So 1 mole of what? CO2 occupies 22.4 dm. That's what Avogadro law. 1 mole of any gas occupies 22.4 dm. So 1 times what? 1 times 22.4 dm. If it is 2 mole, you multiply by what? 2. So of what? CO2. So we are converting this one into gram because we are asked to use gram. So that's why we are taking this one to gram. So assuming it is a mole, you can leave it as mole. So this one is 2 into bracket 23 plus 1 plus 13 plus what? 48 of NaHO gives what? 22.4 dm3 of CO2. So meaning that when you multiply this one together, this one will be 2 in bracket 84 of NaCO3 to give what? 22.4 dm3 of CO2. So this one now will now give what? 16.8 gram now of NaCO3 is equal to now, you cross multiply 16.8 cross multiply like this. 16.8 times what? 22.4 dl cube all over what? 2 times 2 in the bracket what? 80 what? 4. So 2 times 84, which is 168. So when you multiply this one times this, what do you get? So 2 here we cancel. It will be 11 point what? 2. So 16.8 times 11.2. What are we going to have? Then divided by what? 84. 16.8 times 11.2 divided by 84 will give you what? Give you 22.24 dm cube of CO2. So that's what will give you 22.24 dm cube of CO2 when you press on calculator. So I think so. The option is what? C. Option is C. So that's that about, we can see this Avogadro, but it relates the most to volume, and then we change the most towards gram so that we can relate it with what? 1 molar volume of CO2. So then we substitute our 6.8 gram of NHCO3 to get our volume of our CO2. Now we have come to the end of today's class. Please remember to what? To press the like button and subscribe to the YouTube channel if you have not done that. Please and please let us know how this video has helped you. Remember to what? To subscribe and what? Keep on watching what videos online academic tutorial. Thanks for your time today. We look forward to see you next time.